Hello everyone, welcome to today's class. We have this challenging algebraic equation before us here. The question looks simple, but how do we solve for the value of k? In other words, does k has a value or it doesn't have a value? So if it doesn't have a value, then we'll know. All right. Now I've solved a similar challenge of this kind already, and I was able to explain the scenarios within or surrounding the premises of this algebraic challenge. Okay, so firstly, let's take our solution. So let's take our solution. Now, let's put the question down. We have here k plus r5 is equals to k. Again, in this kind of challenge, never use square both sides of the equation like most math tutor do online now. Okay, it's okay, take the square of both sides. So when you square both sides, at the end you got an answer that does not fit into the system. Here we cannot square both sides of the equation. So what we do here now, let's subtract k from both sides of the equation. Okay, and again subtract 5 from both sides of the equation. And so this is going to give us our k, then plus our 5 minus our k, then minus our 5 equals to our k, then minus our k minus our 5. So what happened? This and this will leave the system. So we are now left with our k minus our k here. They're equal to, here, this and this will leave. We now have minus our 5 on this other side. Here we are having invisible plus here. So we're going to have here our plus k minus k will still give us 0. So this is going to give us 0 equal to, on this side we are left with our 5. But 0, as we all know, is not equal to minus 5. So it shows that solving this using this approach will not work out. If you even go ahead to square both sides of the equation, then the answer you're going to get, if you plug it into the system, it will not still work out. But if you use the graphical method to solve this question, you're going to come up with something special. K is going to give you plus minus infinity. Okay, so if you use the graphical method, you're going to have your k equal to your plus minus your infinity. How? If you plug this part of this equation, the left-hand side of this equation, on your graph, then you're going to have your graph is going to cut through positive 5 on the y-axis and negative 5 on the x-axis. And this side of the graph, which is the right-hand side, is going to pass through the origin down and up, right? So it's going to pass through the point of intersection of your x and y, which is the origin rather. So if you pass through that, the two lines, this is what I'm saying here. Let's assume we have this, we have our y-axis, we have our x-axis. This side we have negative of our y, then here we have negative of our x-axis here. Then this is your starting point, which is the origin. If we mark here to be our 5, we mark here to be our negative 5, then we mark here to be our negative 5, then we mark here to be our positive 5 for x. If you plot this graph, the first part, which is the left-hand side, is going to pass through this and this. And so you're going to have a straight line. Okay, so let's move this to this way, sorry. So this is my negative 5 here. All right, so this is my negative 5 here. So it's going to pass through this point down. And this is your y. We have your y is equal to your k plus our 5 here. Then if you plug this on this same graph, it's going to pass through the origin here. Okay? Right. So it's going to pass through the origin again. So these two lines here, they are parallel. They can never meet. That is just the simple truth. So they will tend to infinity. No matter how far you draw this line and this line, they cannot meet. Okay, so they will tend to infinity also. And so this side is positive, and if you do that to this other side downward, it is negative. But how do we solve for this positive and negative infinity without squaring both sides of the equation? So this is how to solve for that. So let's take the other method. So we take our question again. Let's take it, or let's use from here. So from here, we have our k, then plus our 5 equal to our k. All right. So what you do here is this. Divide by this variable k. So if we divide by k, we equally divide this by k, equally divide this by k. So this, 1, 1. This, 1, 1. And so we're going to have here 1 plus our 5 all over k equal to 1. Right? Subtract 1 from both sides of the equation. So we're going to have here 1 plus our 5 all over k equal to 1. All right. 1 plus 5 all over k. Then minus our 1 equal to 1 minus 1. This and this leave the system. We are now having 5 all over k is equal to 0. So if you decide to multiply through by k, this is going to give us 5 equal to 0. And 5 is not equal to 0. So what we do here, so it's a simple manipulation I thought of. So what we do, we just have to find the reciprocal of both sides of the equation. We know we cannot divide by 0, but finding the reciprocal is different from dividing through by 0. So if we find the reciprocal of everything here, this is going to give us 1 all over 5 all over k is equals to 1 all over 0. We only find the reciprocal. We didn't divide by 0. Get that clear? And so this is going to give us our k all over 5, right, is equal to our 1 all over 0. Then the question is, what is 1 all over 0? 1 all over 0 is undefined, right? 1 all over 0 is undefined. But let's go on here. But since this one is undefined, we are looking for k, so we have to eliminate this. So we multiply through by 5. So this is going to give us our k all over 5 times 5 is equal to our 1 all over 5. Sorry, 1 all over 0 rather. So going to have this 1 all over 0 then times our 5, right? So this leaves, so we now have k is equal to our 5 all over 0. Again, 5 all over 0 is undefined, right? So if you try to find this out, this will tend to infinity. I explained that in the other video. Okay, I'm going to leave a link in the first video I've made so far on a question that has to do with something of this kind. Okay, where I was able to prove that this is equally to infinity. This will tend to infinity. Okay, so our k therefore is going to give us our plus minus infinity, because we said this is undefined. But I analyze this very particular point we have here, 5 all over 0. I was able to, explain what happens under this, why this expression is termed undefined. Okay, and when I did that, it tends to infinity. Everything tends to infinity. And so with the help of this method, this correspond with the graphical method. But the question now is this: is k equal to plus minus infinity the answer? The answer to that question is no. It is not the answer. Because infinity is not a number. Infinity is just a concept. Okay? Infinity doesn't exist. That is just the simple truth. Infinity doesn't exist. So what happened? K equal to plus minus infinity is not an answer that satisfies this challenge. So in all, we just conclude that there is no solution. There is no solution to this maths problem. There's no solution to this math problem. I brought this just to prove that if you plot the graph, it's going to give you infinity. So how do we solve for that infinity graphically? Algebraically. That is the essence of this video. Thank you for being there. See you in our next class. Till there, keep winning. Do not forget to drop comment in the comment section. Bye for now.